Welcome back to the exam preparation video series for DP-100, Designing and Implementing a Data Science Solution on Azure. I'm Aravind Sridharan, a Microsoft technical trainer. This is the third episode out of a total of 4 episodes in this series. In this episode, we'll focus on training and deploying models. We'll cover how to run training model scripts, implement training pipelines, manage models, and deploy a model. Here's a list of all the different skills you may or may not be tested on. These are sometimes referred to as may include, meaning they may or may not be on your exam. This list isn't exhaustive, and while we won't be covering every skill in this video, be sure to be able to perform these skills before taking the exam. We'll be focused on command jobs in 3.1 and custom components when implementing training pipelines in 3.2. In 3.3, we focus on the artifacts during the inference time, and in 3.4, we'll cover how the different options one has when it comes to deploying models. To consume or read data in a job, you can use the input class. This is important because it allows you to define both the type and the path of where the data is located, ensuring proper data handling in your machine learning workflows. The fields to define the input class are the type, which defines the type of data you're working with, such as file, directory, or dataset. The path, which specifies the location of your data, which can be a local path or a path in cloud storage or another accessible data source. The main thing I want to call out here is that using the input class correctly ensures that your data is accurately read and utilized within your jobs. Use the reference documentation when you start defining a job. Understand that curated environments are provided by Azure Machine Learning and are available in your workspace by default. They allow you to get started with various machine learning frameworks. The custom environments allows for more changes to be made to existing environments or can be created from scratch, which offer more flexibility for you to tailor them to your specific needs. The packages need to be installed on the compute. Know how to track and view job metrics using MLflow in Azure Machine Learning. MLflow is essential for tracking your experiments. It allows you to log parameters, metrics, and artifacts during training runs, maintaining a detailed record. Log metrics like accuracy and loss during your run. These can be viewed later in the MLflow UI, which provides detailed visualizations and comparisons. Know that what the ML Studio is, and don't confuse it with MLflow. Azure ML Studio offers a dashboard for visualizing and comparing metrics, helping you identify trends and improve your model. Effective tracking and viewing of metrics give you insights into your model's performance, enabling continuous optimization. MLflow also works in command jobs and is not limited to experiments. As mentioned in the previous slide, MLflow simplifies the process of logging parameters used in machine learning jobs. Parameters can be of any type and are essential for documenting the configurations used during experiments. To log parameters, you can use a straightforward syntax. For example, if you want to log the number of epochs used in your training job, you would use mlflow.log_param. And number of epochs would be set to 20. This logs the parameter number of epochs with a value of 20. By logging parameters, you ensure that all configurations are tracked, making it easier to reproduce experiments, compare runs, and fine-tune your models. Understand the key steps to run a Python script. Submit your run in the cloud and view the output. To run a Python script and to run it locally, write and save your Python script and run it in the terminal. The terminal will provide you with the output and allows you to run it locally for interactive debugging. To submit and run code in the cloud, you can create an experiment in your Azure Machine Learning workspace, upload your script, use the Azure ML client to submit the script, initialize the ML script, and submit the run. You have to know how to use logs to troubleshoot run errors. Some steps to consider are: Step 1, select the pipeline run, choose the specific pipeline you want to run. Step 2, review the log files by navigating to Output plus Logs tab on the details page. The main thing I want to call out here is that reviewing the log files from the pipeline run detail page is crucial for effective troubleshooting. Recognize the value of Azure Machine Learning components that is self-contained as a piece of code that performs one step in an ML pipeline. This is important for modularizing and reusing code effectively. Creating components can be done using two methods. By using the Python function, prepare the Python script. The script contains the execution logic of your component. It defines the component interface by specifying the inputs and the outputs, and by using YAML definition. Add other metadata. This includes runtime environments, commands to run the component, and additional settings. Both methods ensure that your workflow is streamlined and efficient. Be aware of the high-level steps to create a pipeline. Step 1, prepare the input data to ensure your input data is ready for the pipeline job. Step 2, define components to prepare, train, and store the data. Then compose the pipeline and assemble these components into a coherent pipeline. Then you get access to the workspace with compute to secure the Azure ML workspace and the required compute resources. Submit your assembled pipeline for execution, and once the job is complete, review the output of the components. You can also register the component for further reuse and sharing it within your workspace. This step is highly optional, but recommended for efficiency. You should know how to define input and output parameters, which is crucial for passing data between steps in a pipeline. Input parameters define the data type and the path where the input data is located. Output parameters specify the output data that will be stored and its type. And passing data between the steps, you must define the input and output parameters while creating a component. Understand how to monitor and troubleshoot pipeline runs effectively using Azure Monitor. This is essential for maintaining the availability, performance, and operation of your resources. To analyze metrics, all metrics for Azure ML are in the Azure Machine Learning Service Workspace namespace. For metrics supporting dimensions, apply the filters using dimensions or split metrics by dimension. To visualize metrics, use Azure Monitor to create dashboards for better visualization and analysis of your metrics. To analyze logs, logs in Azure Monitor are stored in tables, each with unique properties. You can also create a workspace monitoring dashboard using templates for a comprehensive overview. To access alerts, you can use Azure Machine Learning from the Azure Monitor menu. Common alert types include model deploy failed, quota utilization percentage, and unusable nodes. Know what the ML flow model format is, which allows us to standardize how machine learning models are packaged and shared. ML flow model adopts the ML model format to create a contract between the artifacts and what they represent. This is important to understand. The major elements of an MLflow model format include flavors, which are the different ways in which the model can be used, such as serving with MLflow or loading it with a specific library. Signatures, which specify the model's input and output schema, ensuring consistency and correctness when the model is used. The environment, which provides information about the dependencies and the runtime environment needed to run the model. And the predict functions, which detail on how to invoke the model to make predictions, often including the exact code or API calls required. To package a feature retrieval specification with a model artifact, it's essential to include the specification in the root folder of the model artifact. This practice ensures proper lineage tracking and accurate model inference. For models registered in an Azure Machine Learning workspace, the lineage between the model and the feature sets is tracked only if the feature retrieval specification exists in the model artifact. At inference time, the scoring code must load the featured list from the feature list specification found in the model artifact folder. Recall the two types of ways to register models in a registry using MLflow SDK. Method 1 is from an existing run. If you have an MLflow model logged inside a run and you want to register it, use the run ID and the path where the model is logged. Method 2, from local assets. Create models from assets. If you have a folder with an ML model, MLflow model, you can register it directly using the URI schema. The main thing I want to call out here is that these methods ensure your models are accessible and manageable from your Azure ML workspace. Understand the 3 stages of model debugging to ensure your models perform accurately and fairly. Identify. Understand and recognize errors. Detect model errors and fairness issues. Diagnose. Explore the causes of errors. Investigate the underlying reasons for the identified errors. Mitigate. Take targeted mitigation steps. Use insights from identification and diagnosis to address the issues. Implement strategies to enhance model accuracy and fairness. Consider both social and technical solutions to mitigate the identified issues. You can also use the Responsible AI dashboard to support model debugging. Know that using these 3 stages and tools helps ensure your models to be reliable and fair. Know the tools that are brought together by the Responsible AI dashboard. For error analysis, to view and understand how errors are distributed in your dataset, Data Explorer allows you to explore your dataset distributions and statistics. The Model Overview and Fairness Assessment feature allows you to evaluate the performance of your model and evaluate the model's group fairness issues. Together, these tools will help you debug machine learning models while informing you of your data-driven and model-driven business decisions. You will need to use various tools to holistically evaluate their models and data. If you discover a fairness issue with one tool, jump to a different tool to understand what the data or model factors lie at the root of this issue before taking any steps on mitigation. By using the Responsible AI dashboard, you can create dataset cohorts, pass these cohorts to all the supported components, and observe your model health for your identified cohorts. Understand the process around online deployments. The key configuration settings for real-time deployments are: specify a unique name for your deployment configuration. Define the endpoint name. where the model will be deployed. Register and select the model to be deployed and ensure it is correctly packaged and versioned. Define the runtime environment, including the dependencies and libraries needed for that particular model to run. Then set up the code configuration, specifying the directory containing your storing script. Choose the type of compute instance to be used for that deployment. And finally, specify the number of instances for scaling this particular deployment. Recall the steps to create a managed online endpoint. Configure the online endpoint by defining and creating a configuration file. Specify details such as the name and authentication methods. Then you create an endpoint by using the Azure CLI or Python SDK to run the creation command from the endpoint. Then you configure that online endpoint and create a configuration file for your deployment by specifying the model, environment, instance type, and count. And finally, you create the deployment. You execute the deployment command to apply the configuration to the endpoint. Recall the Python code to send a request using a JSON file. This step helps you validate the deployment and check if the model is responding to you as expected. To invoke the online endpoint, the code is set so that it includes 3 parameters: the endpoint name, the request file, which is the file that contains the request data, and the deployment name. Remember, the steps to configure the job run involve configuring the endpoint. Use the Azure CLI, Python SDK, or REST API to define the endpoint settings, which include the endpoint name and authentication methods. Then you create that endpoint, you execute the command to create the endpoint in your Azure Machine Learning workspace. Then you configure the deployment and define the deployment settings, such as model, environment, instance type, and count. Then you create the deployment and run the command to create the deployment based on the configuration settings. Remember that to deploy a model, you will need to have an existing batch endpoint or create one before adding deployments. The 2 ways to add a deployment are via the Azure ML Studio, which is to use the intuitive UI to navigate to your batch endpoint and add the deployment. You can also do this from the models page as well, where you can create an endpoint or use an existing one. Recall that to invoke a batch endpoint, you use the invoke command with 3 key parameters. The key parameters are the endpoint name, the input, which is provided by the data source that the batch endpoint will access, and the deployment name. Remember that these parameters help streamline batch operations and improve the data processing efficiency. To recap, in this episode, we discussed how to run the model training scripts, implement training pipelines, manage models, and deploy a model. Remember, this group accounts for 20 to 25% of the exam, so keep that in mind when preparing for the exam. Thank you for watching episode 3 on training and deploying models. Be sure to join us for episode 4, where we cover optimizing large language models for AI applications.